Welcome to Chapter 1, Programming Language Programmatics. In this chapter, I will give you the introduction for programming language course, especially for the design of programming languages and the different kind of programming languages. Let's get started. My name is Eric Chou. There are a lot of different programming languages existing in current industry. We have JavaScript, Python, Java, Ruby, SQL. Some people call it SQL, PHP, Bash, C#, and different languages. And this course is to study the feature of these different languages and also about the design of compilers for these different languages so that your machine can understand what the programmer is about to perform some instruction on the machines. So this course is about the design of the languages, the design of the compilers, and also about the features of the languages and how to pick a good programming language. At the lowest level, we have the machine code. It is usually unreadable, and machine code is in the binary format. But right here we have the memory dump. It is in the half byte format, so you have the 4 for 1 half byte, and then another 4 in combined become 1 byte. And this is the core dump of a memory location. So the machine code can be in such a binary format or byte format, and we have the memory dump to show how the program is really stored in the memory or your disk. Here is the simple representation for the binary information, but sometimes it doesn't make too much sense. We are not going to touch this too much because it is very straightforward and very hard to understand. The second level is a level higher than the machine code. It's called assembly language. Right here is one example for the assembly language for the Intel x86 family for the GCD code. So right here we have the GCD algorithm written in assembly code. And as you can see, you have an instruction, have some operand. The operand can be a memory location or some register. Sometimes there are some label. And the assembly language is to help you to write some assembly code that can be translated to machine code quite easily, so you can control your machine very straightforwardly. And it is more understandable than the machine code, but compared to high-level languages, it is still too tedious. And at the high-level languages, is the most popular languages are listed here. The efficiency of the assembly code can be higher, but high-level languages are more readable, so people would like to use this for programming more often. And here are the popular languages in the year 2016. And here is the timeline for the development of different languages in the category. We have logic languages, we have functional languages, concurrent languages, imperative languages, and the object-oriented languages. And as you can see, the imperative languages is the majority of the languages. Some languages are in between, and actually Java is imperial language and also is a object-oriented language. Besides, it is also considered as one of the functional languages. So this chart doesn't show the aspect of each of the language completely. Here just show you the trend and the timeline of the development time of each of the languages. In this course, we are going to introduce these different language families, and we will be comparing them and study them in this course. Why are there so many programming languages? There are a lot of reasons. First is evolution. Over the time, hardware keep improving and the computer architecture keep improving. There are a lot of new features coming in, And also there are a lot of need. For example, like network programming or mobile device programming, they all bring in a lot of new needs for the development of programming languages. So this is one factor for evolution. Second is the socio-economical factors. For example, some company would like to own their own language. That's a proprietary interest or commercial advantage. For example, like Java is developed by Sun Micro, and then later Sun Micro system company is acquired by Oracle. So some company like Oracle, they would like to keep owning that language for a longer time to gain some commercial advantage. And there are also some other reasons, like special purpose programming language. Some languages are designed for certain special purpose. For example, Verilog is used for the hardware description language, or VHDL for the same thing, and some languages like SPICE is used for analog circuit design and simulation. And these are the special purpose languages. And also, there are some languages used for certain special hardware or special devices. For example, Swift is a language developer for the iOS app application development. And here is one website you can look at it for the details. What makes a language successful? Some languages are easy to learn, for example, like BASIC, Pascal, and some languages are easy to express things, easy to use, for example, like C, Common Lisp, and these different languages. Some languages are easy to implement, for example, like BASIC, Force, Python. It is easy for you to implement a certain idea using this language. And some languages are very close to the machine code, so it's easy to compile, it is fast and small code. And some languages are developed to back up certain sponsors, for example, like Visual Basic and C# by Microsoft. Some are wide dissemination at the minimum cost, for example, those languages developed by the universities or using for the browsers. Why do we have different languages? What is the language for? A language is used for you to think. So they provide different way of thinking. Sometimes we call it programming paradigm. You use different programming paradigm to develop your own good algorithms or some computation models. Some languages are designed from the user's point of view to help people do programming more efficiently. And some are developed for the abstraction of virtual machine. It's a way of specifying what you want. And some design for the hardware to do without getting to the bits, to make sure that you can translate the language into machine code quite easily. Some languages are for the implementator's point of view. Here are the summary for this lecture. We point out what is the purpose, important language design goals, to follow the evolution path, and some language design for special purpose, some design for personal preference, and the language need to have good expressive power, so that people, and ease of use is very important, easy to implement. And standardization. Standardization will make sure a language can spread out quick and easy. And open source, so that people would like to download. Excellent compiler, so you don't need to take to develop your software. And finally, is the economical reason or petrol reason, so that some company would like to pick it up. And these are the important design features for the languages. And in the future lectures and chapters, we are going to discuss more of what is a good language design, and also analyze different design style and different programming paradigms. Thank you. Bye.